So welcome back to Newcastle Central. In this video, what I kind of want to go over is trying to set up a whole bunch of this equipment from Tam Valley Depot. I've had problems with the Seeps PM1 point motors on the layout here for quite some time now, and what I'm wanting to do is move over to these servo-based micro switches. So it's just a small little servo attached to a 3D printed bracket, and it's got a reed switch on the bottom as well, so that it's able to do the frog polarity. I'm going to be running it through an Octopus 3, which allows me to connect up to 8 servos at one time, and just have one board in terms of one power feed that comes into that. I'm also going to try connecting it up through an Octocoder that sits on top of the Octopus, and that the servos actually connect into here. It's my toggle switches that will then connect into the Octopus 3. The Octocoder allows me to then essentially assign a DCC address to each of those micro switches. So the idea is that, as well as being able to have a toggle switch from the panel that we've got down here, I can either throw the toggle switch to be able to throw one of the points, or I'll be able to do it through a DCC addressing. I've also then got a remote aligner here, which is designed to connect into the accessory port of the Octopus 3, and so that should hopefully let me get the micro switches and servos aligned underneath each of the points, and then basically go through with a remote programmer to be able to then set the center of the servo, to set the speed of the throw of the servo, how the distance and travel of the servo as well, and go through and essentially program all of that into the board. I said quickly in the last catch-up video where I introduced what I was going to be working on that yes, absolutely, I could be doing this through an Arduino, through a Raspberry Pi, something like that. I have got some amount of that already going on. I use an NCE power cab, but I actually use JMRI that runs on a Raspberry Pi for the entire layout. That's all the control that you see when I'm doing running sessions. It's not really through the NCE power cab. It's almost always going to be through Y-throttle or engine driver, depending if I'm on the iPad or if I'm on my Android phone. NCE is what's controlling the signaling, but I actually do everything via Wi-Fi through JMRI that runs on a Raspberry Pi. So I'm very comfortable with doing that. I've also got an Arduino that's then controlling some of the signaling that's on the layout as well. So you absolutely could do this. Honestly, it's kind of a convenience thing for me in that I didn't want to try and figure out mounting brackets for these. So this comes with a 3D printed bracket already. It's already got the servo attached to that. It's already got the switch attached to it and stuff like that. So this is kind of a convenience thing. I wanted to figure out how to do it. Again, I kind of introduced this on the last video where I was talking about what I was going to be getting up to, but these run about, I think, $12 each. The Octopus 3 is about $45 to do the 8 servos. The Octocoder is about $20 to be able to control it, and then the remote aligner you only need to buy one time. I think that's about $15-20 as well, something like that. So that's all US dollars. So I guess we're at what, £8 UK, £35 UK, £12 UK, and then again about £12-15 UK, something like that. So the idea is that this should run me about 18 to 20 US dollars for each point motor to have both the point motor, the frog polarity being able to get thrown, and to have DCC control, which is about 12 to 13, 14 pounds maybe UK for essentially complete DCC control through the toggle switches that I've already got on the switch panel. So let's get all this stuff out of a bag. Let's start to play around and get stuff connected up and see if it actually lines up with all the hype and what they said on there. So at least so far, this is frighteningly easy, which is kind of what I was going for with this. So all that we have at the moment is the servo connected into the servo bank, and I think on the previous video I had them swapped around. Servos on the bottom, toggles on the side. And there's two different jumpers that you got here. This is in the run position. You can also then do a line, and so what you can set up is move it into the align, and I've got that remote aligner already set up. And then what you would do for real is then another jumper here for center. So watch the servo. When I put it onto center, the servo then centers. So at this point, that's where you go ahead and mount. You would have the rails, the point, in the middle, So what you can do is take one of the black ties, spare black ties, and just put those on either side of the rail on the point, and that's enough to keep it centered. So you go ahead and mount that. When you're done, you can take off center and then watch the servo again. So that's now essentially moved off to one of the sides. Now, you can do here at this point is say, okay, I want to go ahead and I want to go and move on to the next servo, and so you can see they're moving through all the different servos that you can work on. I'm on servo 0. So press and hold. And so now I'm already set up so that I can go ahead and then choose what speed I want. So it's already kind of set in the middle, but if I want to, I can go ahead and choose to speed it up or to slow it down, however I want to do. And you can see that light moves. So if I want to speed up the movement, it moves that way. So I'm going to go ahead and put it about in the middle. What I would then do at this point is go ahead and start to do an automatic alignment. And so what you can see very, very slowly, that servo is starting to move around. What you would end up with when that finishes, and it can take a minute or two. I'm not entirely sure if it's meant to be sensing force at this point, so it knows once it's got off to the side, but essentially what it's doing is figuring out how far left it can go, how far right it can go. This isn't going to do a whole lot because I don't have it connected, so I'm going to just pause the video here and wait until this is finished. And come back. Okay, so it's gone ahead and finished what would be its automatic alignment. And again, I'm assuming it's meant to be sensing force, so it knows when it's at the side to stop moving. So we're still in a line. We haven't changed anything, but now what we can do is say, okay, swap. I'll hold it up to make it a little bit easier to see. And so as we then press the swap button, it then throws one way and the other. And it's also throwing the switch on the bottom. It's kind of hard to see, but it is just enough there that it will then close and then release, and so that's what's going to be throwing the frog polarity as well. And once this is mounted, again, we could adjust the speed that moves, which again was one of the advantages of doing something like the Octopus 3. I can go ahead and decide exactly how fast I want that to move. So you could do like a tortoise where it's a little bit of a slow movement. I actually do kind of like this where it's probably a little bit faster than a tortoise would be. I'm not sure about some of the cobalt ranges. I think that's probably about the same kind of speed as a cobalt, but I could slow it down a little bit, again, to make it even more prototypical. The one thing that I found about solenoids like the Seeps PM1, and if I had gone for the Pico, was a PL10, is it's very much a bump on bump. It just throws it as the power is thrown. If you go through a capacitor discharge unit, as it drops the power and throws it, so it's a very sudden thunk. The capacitor discharge unit does somewhat lighten the noise a little bit, but I do like that this is a little bit more of a sedate and a little bit more of a gentle throw. So what you would then do, once you would have those aligned, so you go ahead and do all 8, you would then move this back over into the run position like that, and now ready. So this can still connect and it can still do the throws. It can't do, I don't believe it can do the alignments, but you can still test it and throw it. And again, the idea here is, I think this is a 6-foot cable that I've got, and so I'm not having to lay underneath the layout and test this and figure out, okay, I don't need to throw a toggle. I've got nothing wired up. I don't have any toggle switches wired up. I haven't done anything for the frog polarity yet, but it means I can easily test this and see how all of this works and know that I'm going to be good to go. So the next thing that I'm going to do is probably wire up a toggle switch, just to see how that would work, and hopefully it should be the same. I'll throw the toggle switch one way and the point will throw. Okay, so this took a little bit more figuring out than I was kind of hoping it was going to be, and have run into somewhat of a problem. So what we do have is movement, so at least it is working. I can throw a toggle switch and it will throw correctly. I haven't wired up the frog polarity and DCC part because there's no point in doing that until I get it connected. That's just one that I know is going to work. That's already pre-built. I just need to wire it up. Notice I'm being kind of careful as to the orientation of this toggle switch. So these are the toggle switches that I use on the switch panel, and they had to be center off toggle switches because when I was doing the Seeps PM1, using a capacitor discharge unit, and so you couldn't have the switch thrown like that and left. There's actually a couple of different reasons. One is essentially it would burn out the point motor if you were just connecting them directly. If you're going through a capacitor discharge unit, then what's happening is the capacitor is discharged and at no point is it able to recharge. And so what would happen is, in normal operation on my layout right now, that's what happens. You will throw the point and then you would immediately bring it back to center. Essentially, discharge the capacitor to throw the point and then bring it back to center. The capacitor can then recharge. So on the switch panel, this is the normal behavior of all of the points, of all of the switches rather, that's centered. When you want to throw, you would then do that, and then it would actually come back to the middle. When you want to throw, you go down, and you go back to the middle. This is a little different. Center off I don't think, I need a little bit more. Center off isn't working. And so it actually has to be wired up. This is doing functionally nothing. And so what I'm doing, I guess I could go the other way to be honest, is that nothing will happen when I throw that way. I've got to go that way. So what I've got on my layout is actually center here is what I then wired off to be able to drive the LEDs. It's the two outer legs is what actually runs off to the SEEPS PM1s. So what I had been hoping was that I could just reuse all of the switching, all of the wiring that I had from the SEEPS PM1s and literally just snip the PM1s and then drop this in, essentially put in these female jumpers to be able to say, okay, this is coming from the switch panel where the SEEPS PM1s are. I'm now going to just add in the female jumpers and connect them into the Octopus 3. Fortunately, it doesn't look like that's going to work. So I need to do a little bit more research. It wouldn't be the end of the world necessarily if we kind of take a step back. We take a step back on the switch panel. I said, it somewhat works with doing the LEDs, but we have some problems here, and I think it's just because they're not working, or actually there's a lot that aren't working if that's the case. So it wasn't perfect in how I was doing the LEDs, and what I would have ideally wanted to do was do a double pole double throw switch. I'm pretty sure that if I had done that, then it would have been a lot easier than wiring the LEDs from there, and then depending on which way the switch is thrown, it would work. I also can't do center off, so I'm trying to find in my bag of tricks. I do have a bunch of these, so again, it's not a big deal. I have the switches where it's just one way or the other. So I didn't really want to do this. I certainly can. It's actually not that big of a deal. Underneath the switch panel, all of the leads run off to essentially connection blocks underneath. It would just mean that I would have to disconnect all of those and essentially then wire in a whole bunch additional switches and then redo the LEDs. Again, these I actually want to switch to a double pole double throw rather than single pole. So yeah, I would need to get some double pole switches. So it's not the end of the world, and I think rather than trying to figure out how I can jury rig it with this, I would rather do it right. Again, in hindsight, I should probably have put in double pole switches, even double pole center off switches to begin with. So yeah, a little bit of a side guess. I was hoping it was going to be fairly straightforward. At least it does all work though, and again, it's just validation of how easy is this. Well, it's just like, yeah, once you have the right switches, it's really easy. If you take away the center off, then it would be working just fine. There's not a whole lot to do to it. So I'm going to drop the Octocoder on top, just so I can then test that out. And I think the next step would be get some replacement switches. Okay, so this is now with the Octocoder installed on top of the Octopus 3, and it literally just plugs on top of where we had the toggles connected. Really kind of cool in that, okay, we can, and I'm using the power cab just to make it a little bit easier, so if anyone would get confused by why throttle our engine driver This is just a regular NC power cab. So you can choose what you want. So select accessory, let's go, and I've programmed this on 17, and we want to have it normal, I want to throw them. So there we go. The Octocoder works in blocks of 8 digits in terms of servo 1, 2, 3, 4, 5, 6, 7, actually 0, 1, 2, 3, 4, 5, 6, 7. So it's like, well, how do you program that? So as with everything, there's a little jumper, and so you put it onto the address jumper. And it's flashing it now. And all we've got coming into this, forgot to say at the start, all we have coming in is our DCC in. That's it. That's all there is that drives this. So let's go in and we'll say it's time. It starts in blocks of 8, like 1, 9, 17, 25. So now let's say we want this to be 25. And watch the flashing lights. So it knows that it's up to something, and then let's say we'll throw it. So now that light's gone away. Take off the address jumper, we'll go in 25 and throw it. And so whereas what had before been 17, just throw it, nothing happens because we programmed it to 25. The only do is that that first one, if I plugged in a second servo, that would be 26. If I plug in a third servo, that would be 27. So that's just, again, show how that works. Put on the address. Say, okay, come in and do 17. Now we want to throw it. And that's just kind of program that first bank of addresses, take off address, come in, and we were on 17 and 2. Whereas previously we had been on 25, so if we try and get that one, nothing happens. So that's all it takes to program this thing. Put on the address jumper here, pick the starting block of 8, like I say, and the instructions help remind you, 1, 9, 17, 25, 33, 41, 49, just to try and prove I can count in 8s. So you just pick where you want to start. So I would probably go with something like 17 because I'm unlikely to have a road number of any of my locals that would be that low. But I also want to try and avoid 1 through 10 just in case for whatever reason you would put on something like the old Backman Easy command that I had. Or honestly, with the addressing starting at 1, default number for a new decoder when you put it in is going to be 3, so I wouldn't want to be in that first bank anyway. 9 I would probably avoid again just to try and take out those single digits. So I would probably start out with this at 17, but it is kind of cool in that we can say, okay, what was it? So select accessories 17. And then that's all there is to now have DCC control of this. So we've gone from the basic board with the servo, going through the remote programmer, so that we can say, okay, let's center it, let's do the speed of the movement, let's do the alignment and the throw distance, stuff like that. So that was pretty cool. And we saw how we could put a toggle switch in and throw. A little bit of a problem there, but give me a second. And then putting on the Octocoder, and the Octocoder really does make it pretty straightforward. Just to give me a minute, there's another jumper that we didn't have before down here for momentary. When I read the instructions for this, what I totally missed on when I was looking online trying to figure this out, the Octocoder cannot use a toggle switch. It can only be a momentary switch. So that gives me a little bit of pause for thought. It would still work fine. I was going to be swapping out the switches on the switch panel anyway. Actually putting in a push button is a lot easier probably than trying to figure out a double pull, double throw switch. It's something to do with the electronics of it being DCC, is that if you try and connect in a toggle switch, essentially the toggle switches are going to try and fight with what would be the DCC signal that would run over the top of this, and the toggle switch will win. And so from what I can gather is if you plug the toggle switches in here, the toggle switches would work, but the DCC commands wouldn't, because essentially you'd be sending, so let's go with this one right here. This is 0, so this is where we're putting in my toggle switch. 0 is where my servo's connected to. When I would try and send the DCC packet to say, okay, I need to throw the switch, the electronic state of the toggle switch would interfere with that signal, and so it wouldn't be able to get sent. So you can only use a momentary push button from the sounds of it, actually, rather than, let's move away from switch, momentary push button, just to be a little bit clearer, but semantics isn't going to be my strong point here, so probably need to switch out for a push button. I do have some push buttons. I think I'm going to try and grab one just to prove out that this does work. Essentially put in a push button here and then say, okay, I can either do DCC command or I can push the button and have that throw, and then probably call it good, because I need to take a step back and think about how I'm going to do some of the rewiring of the switch panel. So let's see if I can go find a push button and try this out. Okay, so I did go ahead and find a push button and wired that up. So I've added in a second servo. Just ignore this one for now. This is the one that we've been working with this whole time, and so what we should find, I can go ahead and push the button. I can throw that quite happily both ways. I can also come in and say, okay, accessory 17, enter, and we want to throw that. And then I can come back in and do my push button and go the other way. So this at least does work just fine. Like I said, I had gone ahead and put in a second one, so just to show how that idea of, the starting digit of 17, so if we go ahead and do 18 and throw it, and that's it. And I didn't have to do anything here. I didn't have to program any of this. This hasn't gone through any of the centering and stuff like that, but that's fine. Go ahead and throw it back the other way. But it's more, I didn't have to do anything to this. I didn't have to program this. Didn't have to do anything with the octocoder. Once you do that first addressing, for what this first servo would be, so 17, 25, 33, when you then add in your additional servos, you just increment and you get the next one. So without doing anything except plugging in the servo, I've got DCC control of it with a unique address and all that kind of stuff. So if I added in another push button to the next bank over here, then I would be able to do the exact same thing that I'm doing here. I could have either DCC control or I could have the push button control. So I think I'm going to leave it there right now, because I need to go ahead and now try and figure out, okay, what am I doing with the switch panel. We just try and move over quick. We've got this switch panel over here. Again, take out all those toggle switches, which should be fairly straightforward with those connector blocks underneath. I can reuse the wiring that goes from the connector blocks out to where the SEEPs PM1s are. The one thing I need to try and figure out is the LEDs. And I would rather not, I'm not going to put one of these, any of these motors underneath the layout and connect them up just yet, because not so much that I'm lazy, but I know I have competing priorities with work, family, kids, some other hobbies that I have going on. So I know that if I start to connect these up under the layout now, I know from what I can gather, it's going to be pretty quick to go ahead and use this remote programmer to be able to get them sent, to get them aligned and get the speed and whatever set on them. And the convenience of this octocoder means that I fear I wouldn't actually get to doing the switch panel. At least I would have all of the points working. I would have DCC control, so I could still have somewhat reliable running sessions. But I want to try and figure out how I can do those LEDs. I don't think it will be too bad. The Octopus 3 is meant to have an option to be able to do it, I think. I believe one of these outputs maybe can be used to then drive an LED. I need to look a little bit more into that. So if anyone's used this Tam Valley setup and has ideas as to how you can integrate an LED with the push button, I'm pretty sure. I'm just trying to look at the instructions now. These are some of the sample instructions that came with it. So it's talking about an LED with momentary off, but these are all toggle switches. There's nothing indicating push buttons. So I need to figure out how with the push button I will be able to do the same thing. And actually what I ended up kind of cheating with almost on the existing switch panel is I'm pretty sure that I'm doing some kind of bastardization jumpering from what the frog polarity is. I'm pretty sure that's what I've got coming back, to be honest. I think that's what's driving the LEDs, is what power is the frog getting then lights up the LEDs. So I need to double check as to what the center what the center connection on these toggle switches actually are, and kind of go back through the memory as to how I put this thing together. But the LEDs may work just fine by coming off that frog power, and I can just swap out the toggle switches for the momentary push buttons. So I want to figure that out before I start putting these servos underneath, just so that I don't end up in a situation where it's just like, well, I've got DCC control, and then I move on to something else. I've got too many things that are starting to stack up, like signal lights, like these point motors, like the station buildings and weathering track, and all these things are now starting to stack up where I kind of started doing something and then got got distracted by new shiny and stuff like that. So I want to figure out these LEDs first. So if you got any ideas, let me know. Hopefully I'll be back pretty soon once I figure that out. We can start to mount some of these up. So let me know what you think of this. Do you like the idea of it? Do you like kind of the convenience of the Octocoder and the remote programmer? Have you got any tips on mounting these? I think they're going to be fairly straightforward, and they'll mostly be able to center and align themselves, given I can just put center jumper over here, mount them, take off center, and then go with that remote program. But any tips on go ahead and doing that, that would be great. So subscribe, follow along, so you can see the next couple of videos as I make progress here. And thanks for watching. Take care. Bye bye.